Hello everyone, welcome back. Hope you all well. Today we are going to learn about virtual memory and what it is, and demand paging. We will explain it simply in the coming time. So, keep hooked. Now, let me give firstly an example, like I always do. So, have you ever opened too many applications on your computer and suddenly it slows down? Or even your smartphone when you have too many tabs open like Google Chrome and 20 other apps. Okay, so at that time your smartphone or the computer slows down. Okay, but why does it happen? What happens when your RAM isn't enough? Does your computer crash? So it uses something called virtual memory. What is virtual memory? We are going to learn that. In today's video, we will explore what is virtual memory and why do we need it? Why and how does demand paging work? And what are the factors that affect the performance of demand paging? So, without wasting any more time, let us type in. Firstly, what is virtual memory? Something like a student is using a desk to study but also storing books in a nearby shelf when the desk is full. So he is using both the desk and the shelf. Now, virtual memory is like something this. It is a technique that allows a computer to run programs larger than the available RAM by temporarily using disk storage as an extension of RAM. So what happens that your RAM increases by using the disk storage. Let us say your RAM is 8 GB, but it needs something more. So it will use extra by from the disk storage that is already present on a computer. It will create an illusion of a large continuous memory space. Part of the hard drive or the SSD is used as swap space. So what is swap space? It is used to store data that does not fit in the RAM. This allows the system to run more applications than it physically could with only RAM. Now, imagine you have a small study desk or RAM, but a large bookshelf. That is virtual memory that I gave the example in the previous. If your desk fills up with books, you temporarily store some on the bookshelf and bring them back when needed. So that bookshelf is your virtual memory and your study desk, which is small, is your RAM. And they both combine for efficient execution of that process. So how the virtual memory works is the OS divides the programs into pages, right? We have learned about paging in the previous lecture. If you want to learn more about paging, you can refer to our previous lectures. Frequently used programs, pages are then stored in RAM. Less used pages are stored in the hard disk, which is also called swap space. So when needed, pages from the disk are swapped back into the RAM. Now, example, if you are editing a video and the browsing the web at the same time, the system will prioritize the editing process in RAM and moves less used browser tabs to virtual memory because you are not currently using it, right? And the video editing is at the priority level. Then we have demand paging. It is also known as a smart way to use virtual memory. Now, instead of loading the entire program into RAM, only the required pages are loaded when they are needed. It means that instead of loading the entire page into the RAM, only the required pages are loaded when they are needed. Because why to waste space? The pages are loaded on demand, right? Reducing memory uses. If a required page isn't in RAM, a page fault occurs and the operating system fetches it from virtual memory and then replaces it. This saves RAM space and allows more program to run simultaneously. Now think of you in a restaurant. Okay, in the restaurant with a chef who only cooks. when customer order food. It is on demand. Instead of preparing all the dishes in the advance, which waste the time and the resources also, the chef prepares each meal when requested. So moving into the steps in demand paging, a process starts execution, but only essential pages are loaded. Okay, if a required page is missing from RAM, a page fault occurs. The OS retrieves the page from the virtual memory and swap it back and loads into the RAM. The execution resumes once the page is available, obviously. Now, given you an example is when you open a huge Excel file, okay, only the visible portion is loaded into the RAM. As you scroll down, new pages are fetched from virtual memory. For example, if you say there are 1000 rows in that Excel sheet, only those like 50 or 60 that are visible on your screen will load. But as you move down, it will start to load more and more and more. So that is demand paging. But do have problems with this also, like page faults. By regular food, if there are page faults occurring regularly, then it will slow down the whole performance. Then we have thrashing. If a page faults happen too frequently, the system will also spend more time swapping pages than actually executing the processes. Okay, so now coming on to the performance of demand paging, how fast it is from the normal paging. So there are some factors which affect performance, which is critical. Sorry, everyone. Yeah, as I was saying, there are some factors which affect the performance. Firstly, the page fault rate. If the page fault rate is low, demand paging works efficiently. But if the page faults are high, the system performance degrades. Also, the PFR or the page fault rate should be kept minimal to avoid any delays. Then we have the page replacement algorithm. The operating system uses different strategies to decide which page to replace when memory is full. Some of the common algorithms that we use is least recently used. What will it do? Like this, it will remove the least used page from that section. Then we have the first in, first out. As the name suggests, with it will remove the oldest page which comes first, right? And it will keep happening one by one, first in, first out. Then we also have optimal page replacement. It means that the page which will not be needed in the coming process in the execution, it will be removed, making the process more efficient. After this, we have thrashing, what we call. If too many page faults happen, the system enters a state called thrashing. Thrashing means the CPU is spending more time swapping than actually executing the program. It is less efficient. So to solve this, we can increase the RAM or optimize page replacement. Let me take you back to that restaurant. Imagine a chef who forget ingredients and keep running to the store instead of cooking. If this happens too often, customer must wait longer for the food. Similarly, too many page fault will slow down the entire system. So now let us look at the difference between the virtual memory and the physical memory, which is also needed. Firstly, coming on to the speed, obviously, if we have physical memory, it will be very fast because we have already it is available. But in the virtual memory, it is slow because it is swapping, right? Then we have the storage location. So the physical memory is generally stored onto the RAM chips, and the virtual memory is on the disk drive or the SSDs that we have. The capacity limit, obviously, in the Physical memory, there is a limit. If it is 8 GB RAM, then it is 8 GB RAM. We cannot do anything about that. Then we have the virtual memory, it is unlimited. If it has to cross a limit, then it will borrow it from the SSD. So that is unlimited. Then we have page fault. If we have physical memory, there will be no page fault happening anytime. But if we have the virtual memory, a page fault can occur, and it can occur more frequently. Uh, think of it like the RAM as a fast highway, national highway, but a virtual memory like the road in front of your house. It is a very slower, right? So that might give you a better picture. Now, moving further, what we have learned today. So we have learned about three things. Firstly, what is virtual memory? Virtual memory is a technique that extends the RAM using disk storage. Then we learned about demand paging. It means that whenever there is demand, there is paging. It will load only the required pages into the RAM on demand service. Then we looked about the performance of demand paging and how what are the factors that can affect it. We also learned about how page faults and thrashing affect the speed of demand paging. Understanding firstly this all these topics will help us optimize the performance which we are going to build the system, and it will also avoid the slowdowns when handling large applications. So now, as you all see, if you found this video helpful, don't forget to like, share, and subscribe for more tech explorations. See you in the next one. Thank you.